Okay, so there's a song that my kids and I like, also from the past, and it goes something like, but we're never gonna survive unless we get a little crazy. Seal, one of my favorite Seal songs. Anyway, so last class, I got a little bit crazy and I was writing stuff on the board and I was like, oh, sex and this and interactions and error and blah, 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 blah. And I was so excited and so crazy because we were talking about something that I hadn't intended to talk about that I got a little goofy. And we're going to go over things today and try to clarify some of that goofiness. So who wants to have that goofiness clarified? If you want to have that goofiness clarified, raise your hand. All right. It's not everyone. If you want to learn about the differences between experiments, correlational studies, and quasi-experiments, raise your hand. All right, great. I like that attitude. I want to learn everything. Originally, I was thinking about being much meaner and saying like, okay, who doesn't want to learn about this stuff? Raise your hands. And I was going to say, okay, you can leave. Because
that would probably make me cry.
Well, I would have stopped you and said you can stay if you want, but I would imagine that there's going to be a difference between people who want to learn something and people that don't want to learn something in a class, right? How would you expect people that want to learn the course material, how would you expect them to do compared to people who don't want to learn the material? Better, right? And so if we thought about this, let's say performance, better, worse, people who want, and people who no want. No want because they didn't want to learn, maybe they didn't learn grammar that well. I don't want to learn the grammar, so I mess up all the time, especially when I write. Lovely. Anyway, so we expect people who want to do better are going to do better than those who don't want to do better, right? Imagine that we had people participate in an experiment and we were going to ask them to learn about some topic. I don't know what the topic is. You could pick out, imagine something that some people are going to want to learn about and other people really could care less about. So we give them different amounts of time. So imagine, instead of having want and no want down here, we have study time. And this is going to be short. Imagine like we're going to have them read like 2 or 3 paragraphs. And we're going to have them study this material for 5 minutes. And then we'll give them a little quiz on some of the material. And then we'll have them go over the material for another 5 minutes, and then we'll test them again. Okay? On different material, because we don't want to test the same material, because if we do the same material, then they'll do better just by virtue of having already been tested on those components. So we've got 5 minutes, and we've got 10 minutes, right? So how would you predict that people are going to do in the 5-minute condition compared to the 10-minute condition? 10 does better. Right? So we have something like this. Does that make sense? Is this a main effect or an interaction here? It's an effect, right? It's an effect of study time. So this difference between study times, that's our main effect of study time. Now, there's going to be differences. Some people are going to be up here, some people are going to be down there. You're going to have some people near the middle, right? There's going to be this distribution of individuals for the 5 minutes and also for the 10 minutes. And when we're doing our statistical tests, what we're doing is we're comparing the size of this effect or the variability due to the study time or to the variable that we're interested in compared to this variability in both of those conditions, right? And this is the variability of our effect, and this combined, that's the variability of the error, right? I said that we can sum up variances. One thing I didn't say, I think, that's very important to say, is that if you're going to sum up variances, things have to be independent of one another. This means that they can't rely on one another. this has important implications for design, and we'll talk about that in just a little bit. So we have some effect, and we've got some error variance, and we look and see if this effect is significant using statistics, and it may or may not be. But now imagine that we ask the individuals at the end of our study time whether or not they wanted to learn the material. So we're going to have some people that say yes, they did want to learn the material, and other people that say no, they didn't want to learn the material. Does that make sense? So if we consider the people just at the 5-minute study time, how would we expect those who wanted to learn the material do after 5 minutes compared to those who didn't? So, this is want, and this is no want. After 10 minutes, what happens? Same for both of them? So they just...
But want is still going to be higher than no wanna.
Want is still going to be higher than no wanna. So something like this. How did the want group get better after 5 minutes? Maybe they tried harder, they were more motivated. Would we expect this to stay the same after 10 minutes? That difference? Because this now, here we're talking about the difference between want and the difference between no wanna. Is that a main effect or an interaction? Just the difference between want and no wanna. Interaction, interaction, interaction. Anyone else? It's a main effect. It's one variable, whether or not someone wants to or not, right? So the difference between wanting to or not wanting to is an effect. And the question I'm asking, is this the same over here? I'm asking, would we expect an interaction or not? Right now, do I have this plotted as an interaction? No. I've got people shaking their heads no. How do you know that? If they cross, there's an interaction. But that's only one type of interaction. Is there something that we can say about interactions that would be more inclusive? Just like college, we want to accept everybody, right? Everyone should be at home in a college environment.
Maybe once the lines stop being parallel.
Yes, once the lines stop being parallel, right? So if we have something like this where they cross over, well, clearly that's not parallel. But we can have other types of non-parallelity, is that a word? Too. It could be like this, it could be like that, right? You could have a number of ways that the lines could be non-parallel. And notice, let's say if it was like this, what happens? Well, there's an effect of wanting, right? So generally, people who want to learn do better than those that don't. That's a main effect. However, the effect of wanting depends on how much time you have, the way that I've drawn it here, right? So with a little bit of study time, the wanting group does a little bit better than the no wanted group. But after more study time, the wanting group does much better than the no wanting group. I would imagine that the data would look something like this, where there would be an interaction. Does that make sense? Why would I expect that as opposed to just everyone doing the same? So today I was, when I was posting the extra credit experiment opportunity, if you haven't seen the announcement yet, so there are some new experiments that you can participate in for extra credit, get up to 25 points. And one of the experiments, oh my goodness, was it boring, is an object location memory task. And there are like 20 objects on the screen, and they show it to you, I think, for about a minute. And then they take the objects away, and then they present objects again. And your job is to indicate which objects moved. So the first time, I see the objects, and then I see the new objects. Okay, which ones moved? So I struggled with it, and I got some wrong. The second time, they showed the original objects again in the same location, and then they removed them, and then they put up objects, some of which had moved. In fact, I'm pretty sure that all the moved objects were in the same locations they were the first time. Anyway, so I got everything right that second time. And then the third time, I also got everything right. And by that point, I was bored because I had memorized the locations, all of the locations for the original and all of the change locations. So I wasn't really motivated spend more time paying attention. So if you imagine people are studying materials, people that want to learn, it's easy for them to stay vested in the task, stay focused, and keep on going. But if they're not vested, no one's forcing you to study, right? I give you the material, okay, you've got 5 more minutes. If you're like, I don't care about this is dumb, maybe you're not going to spend that next 5 minutes studying as hard as someone who wanted to. So I would predict that that wanted to group would go better. That's an interaction. So let me ask a couple different questions. Ignore this study for just a moment and think back to the study that I indicated originally. So this was want and no wanna. And we said that we have something like this. Imagine that I didn't do this, that I didn't manipulate study time. Everyone just had 5 minutes, right? Everyone has 5 minutes to study, and I asked them if they wanted to or they didn't want to. What type of design is this? Is this an experiment or a correlational study? Correlational study. Why would you say that? That's it. It's not that I'm comparing the two, because I can compare the two in an experiment. But you got it absolutely right. I'm not manipulating anything here, right? You're going to want to do this, and you're not going to, I can't do that. You come to the table with that, right? So I can't assign you to that condition. I can measure it, but I'm not manipulating anything. So this is correlational. And let's take a look at the other type of study. So 5 versus 10 minutes. And we said that we would expect to see data that looked something like that. Imagine that we're not asking them at all about their desires. We just compare their performance at 5 and at 10 minutes. What type of study do we have now? It's an experiment. Why? I manipulated how much time they had to study. Does that make sense? So here, I didn't manipulate anything, correlational study. Here, I manipulated something, and it's an experiment. So, I'm sure of that. Manipulation. And here, this is just measured. I'm going to change these into verbs. Measured, IV, manipulated, IV. What is this? Thing in the middle. An experiment, correlational study, both.
Why do you say both?
So I have the manipulation, right? So this is manipulated. Manip. And I'm measuring this, right? So this is measured. This is a quasi-experiment. What does quasi mean? Can any of you guess what quasi might mean based on this? It doesn't mean two. By. Both? No. What? 4? No. That would be like quadi, I would think. Sort of. Sort of. This is a sort of experiment. It's sort of like an experiment because we have one variable that we're manipulating, right? But it's not a complete experiment because we also have one variable that we're just measuring. So because of that, this is a sort of experiment or a quasi-experiment. If you do a Google search for a quasi-experiment and go through some of the things that pop up on the first page, you'll see that some people refer to quasi-experiments as queasy-experiments. Queasy-experiments. Why do you think someone might think that this is a queasy-experiment? Queasy in the sense of it makes you nauseous. Yes, but we can have something that's purely an experiment that has just as much going on. So last class, I brought up the idea of like an inhibition of return experiment where cued, when we flash a location, people are faster to recognize something that appears there at a short delay, and they're slower at a long delay. So we have short, long, we have cued and uncued. And we can do this. Everyone can receive every combination, right? Actually, that's true, but that's not the point. Sorry. So the point here is that I can manipulate delay, and I can also manipulate which side was cued, right? So I have two things that are roughly equal in complexity. The interactions are a bit different, but that's not that big of a deal. But they both have two variables, each with two levels. This situation, both of these variables are manipulated. This, So it's not the complexity of an experiment that makes things queasy. If you find something queasy, that's probably because that it's hard to think about things in higher dimensions. What do I mean higher dimensions? Well, if you think about each variable as being a dimension, like it's much easier to interpret something like this, where there's just the main effect, than it is to interpret something like this, which has an interaction between two things. We could add some other variable, maybe the type of material, whether it's written in a very dense, hard to comprehend way, or whether it's written fluidly, right? And we might see something else. So if that's our fluid condition, we might see something like this, or really dense. Maybe the people who aren't interested, they're not going to do any better with the study time. And this group, maybe they'll do a little bit better, but not so much. I don't know. In that situation, if we were to superimpose these two, notice that these lines aren't parallel, and neither would this line be with that. So that would be a three-way interaction. Start getting to four-way, five-way interactions. It's, at least for people like me, it's a nightmare. It's hard to wrap your head around more than three-dimensional space. Because we're three-dimensional beings, or if you consider time as a dimension. Anyway, so it's not a Quasi-Experiment because it's hard to interpret. It's a Quasi-Experiment based on its relationship with making causal claims. Which type of thing would you have a better ability to make causal claims about? This one, right? Because everything's manipulated. Here, we haven't manipulated everything, so we can't really be sure if it's a difference between the people who want to and the people who don't want to, or some difference in their environment or their upbringing that would have led them to have those preferences, right? How do we tell? We can't. Anyway, so we have correlational studies in which all of our independent variables are measured. We have experiments where all of our independent variables are manipulated. And we have quasi-experiments where some, it could be 1, it could be 2, it could be 10 of our variables are manipulated. And some, it could be 1, it could be 10, it could be whatever, are measured. So we've got the combination of both. So this is like an experiment, but not completely so. All right. Now let's try, does that make sense to everybody? Difference between correlational, quasi, and experimental? Beautiful. So now let's talk about analyzing things and variance and why certain types of research methods are important when we design studies. Thank you. Okay, actually, let's start with the correlational design first. We're going to get 5 or 10 or 20 people who want to learn the material and the same number of people that don't want to learn the material, right? So if we think about variance, so we have some total amount of variance, and we can break this up into pieces, right? So we have variance of effects. We're going to say effects and interactions to be more general. And variance, let's do to error. Right? I think I mentioned that last class. So we have variance for effect and variance error. So earlier when I did this whole thing, I said that the variance or the variations between our effects, right? This compared to that, that's related to our variance for our effects. What would the error variance be? Remember earlier, all this stuff in here? That's error variance. This is our estimate of how people that don't want to learn something perform, right? So all the variations around that, those are just errors. Differences in people who are paying more attention, paying less attention, aside from just not wanting to, right? Because I might want to, but something happened to me on the way to school today, and I'm not thinking as clearly as I could have otherwise, right? So all of that stuff is related to error variance. Now think about a situation like this. What does each one of these points represent? A data point, yes. What does each data point represent? A person, yeah. Each data point represents a person. Is this within or between subjects designed? Between. This means that each dot over here is not associated with dots over here, right? So each point that represents a person or a subject or a participant is contributing to this variance. We have no way of knowing generally who's faster and who's slower, or who's eaten breakfast and who hasn't. All that stuff is all muddled up into one thing, right? So all of this stuff that's related to individual subjects, that's our error variance. So if we were going to create this for that, we'd have variance total is equal to the variance, I'm going to say wanting, plus variance of our subjects. And in this case, the subjects is just the error. Now, in performing our statistics, we can do a couple things to analyze these data. So what type of test could we run to see if this is really different from one another? Chi-square, independent t-test, one sample t-test, paired t-test, NOVA, paired t-test. Is that right? Yes. Yes? Dakota, what do you think? Is that right?
I think so.
Think so? Yeah,
Oh.
it does. Why are you wrong?
Oh, wait, isn't it a pair?
You can have a paired between. If we took everyone and we matched them on some variable, then we could have them paired, right? Here, the way I said, we don't really have any pairing. At least not the way I set it up. If I said, okay, well, we figured out who was the most intelligent and who was the least, and we paired them together. But even then, the pairing really isn't that meaningful because it's not like we're pairing people up and then splitting them, right? People assign themselves. So this is a between subjects design in which there is no pairing. So what type of t-test do we use? I think I heard it. Yes, we use an independent t-test, right? But regardless of the t-test that we use, we've got two groups. So it's going to look something like x1 minus x2, or the means, right? So this is 1 and this is 2. You have the mean of this minus the mean of that, which gives us this. That's what that is. Now this isn't variance because this isn't squared. It's not even, right? Variance is something different, but variance we know it's in squared units. And what's on the bottom? The standard error of the mean, which is just the standard deviation divided by the appropriate n. Okay, so we have something that's like variance on the top, or more like the standard deviation on top, and something like variance or the standard deviation on the bottom. right? So we are actually, when we're running a t-test, we're comparing this with that. It's just that it's like we've taken the square root of all that. Now the reason that I bring this up is because there's another way that we can analyze these data, and that is with an ANOVA. In an ANOVA, instead of having a t statistic, we have an f statistic. And the basic formula for the f statistic, you're nodding your head, can you tell me what it is? It's a mean squared error, I'm sorry, bad. Mean square effect over mean squared error. That's it. Error. Effect. It's like the same thing except we're squaring things. A mean square, if you think back to variance, we had the sum. I'm going to write it a little bit differently. So n x minus the mean of x squared, right? So it's just the sum of squares divided by n. Well, that's like a mean square. Holy crud. It's variance and variance. Variance is good. Now you can't analyze jack. All right. So to figure out whether we have a significant effect of any variable or a significant interaction between variables, all we need to do is figure out the appropriate mean squares. If we design our experiments properly, everything will be independent of one another. What does this mean? So imagine that I did this the wrong way at first. This one, here we go. So I get people to come in. Let's say I get 100 people to come in. And I have them study for 5 minutes, I test them, I have them study for another 5 minutes, and I test them again. Then I ask them who wanted to learn the material. How many of those 100 wanted to learn the material? You said you don't know? I don't know either. So pick a number.
50%.
50%. You think 50% of the people are going to want to learn the material? I have some experiment. They're coming in to get extra credit for introduction to psychology courses. None. None?
20%.
I don't know. But it's probably not going to be 50%, right? If it's 50%, holy cow, there's been a miracle and everything is balanced in the universe. We have the same number of people that want to, and the same number of people that no want. Balance. Balance is a good thing. But probably we don't have balance. We probably have a ton of people who no want it and a few people that want it. So what could I do to make this design, even though it's quasi-experimental, balanced? Let's say I want to get 50 people that want to and 50 people that don't want to. How could I do that? I could ask them before. That's exactly right. So I could ask a whole bunch of people, maybe 200 people, because I'm not so sure that I'm going to have a whole lot of people that want to. So let's say I get 60 that want to and 140 that don't want to. What can I do at that point? Yeah, I can randomly select 50 of the people that want to, or all 60 of them, and I could randomly select the same number from that other group. And the others I just send on their way. We have balance. Balance is beautiful. It's because when we have balance, that means that now, whether you want to or not, is independent of any other variables that we have. Oh, thank goodness. Which means, what about variances? It means that we can add them up, or better yet, take them out. When we did the t-test, the independent versus the paired, what happened? In the independent, we had, well, the formula was up there a minute ago, we had something that was less powerful than the paired situation. Why? Because in the paired situation, if we paired on something that's meaningful, we were able to take all that variance related to whatever variable that we were pairing and throw it out. Get rid of it. Sweet. So, if we are going to do an ANOVA, we are going to break our variance up into different pieces and analyze those pieces separately. So now let's go back and talk about breaking things up. Let's say that I'm just making crap up here. 5, 10, so this is study time, and this is female and male. What type of design is this? Experimental, correlational, quasi-experimental? Pardon? Quasi? Quasi?
What are you measuring?
What?
What are you measuring? Just the
Sex? Oh, sorry. Yes, it's quasi. I didn't want to do, yes, you're right, quasi. Did not want to do quasi yet. Male, female. Say engineering students. I'm not going to do that. Can't spell it. Math students and psych students. This is performance. So for those of you who are like, oh man, this class is hard, you should take an engineering class. Watch out. Stats and engineering. Woo! Anyway, so let's say that we have something like this. What type of design is this? It's all correlational, right? Because we're just measuring things. We're not manipulating anything. Can we have an effect? I'm not asking if we do here, but could we have an effect of sex? Could have an effect of sex? Could we have an effect of major? Yes, we could. Could we have an interaction between those two? Yes. So if we look at our variance, we could have something like our total variance can be broken up into effects of sex plus effects of major plus, now this isn't an effect, but it's the interaction, and instead of writing interaction, I'm going to write sex times, I'm going to use an asterisk to represent times, by major. Right? Plus error. Sorry, variance related to error. Right? So what's going to serve as our error? Again, imagine we have all of these points around each of these means, right? These are means here. And what does each point represent again? A data point? A person. Each point represents a person. Are these points related to the same people? Does this point here go with that point there? Yes? No? Fight. Yes or no? No. Why not? This person who's a male psych major, are they a math major? No. No, they're not. Each point represents a different person. So, all of our error here is just subjects. Each little variation around each one of those means, it's just all related to the subjects. So we have one term for our error. That's it. Now, imagine a different situation. Let's use the 5 and the 10, and I'm manipulating this variable. And give me something else that I can manipulate. Okay, difficulty. So hard, easy. Right? Let's say I do this completely within. Everyone gets 5 minutes and 10 minutes to study the difficult material. Everyone gets 5 minutes and 10 minutes to study the easy material. Right? So you take the easy, then you take the hard. Everyone gets everything, right? So if everyone gets everything, what type of design is that? It's a completely within subject's design. So now let's look and see how we can break up our variance. Anyone want to help me out? Time. Difficulty, I'm just going to say diff. Time. By difficulty, this is the interaction. Plus error variance. So what is our error variance here? I'm going to start erasing this. Boom. All right, so I'm claiming that the error variance can be broken up into what? Oh, I ran too fast on my head. What do each one of these points represent? All the set, or sorry, do we have 1 point from each person in each location? Yes, it's a fully within design. So earlier in our fully between subjects design, so between error was just the variability of the subjects. Here, I'm going to break things down. So within, we're going to break it up into multiple things. Think about it. Are some people just generally better performing than others? Yes. So some of the variance that's related to subjects is going to be, some people are faster than some others. So we will have some variance that's related to subjects. Does that make sense? So if that's the case, when we're talking about like you're generally better than you are, and you're generally better than she is, and she's generally better than you are, sorry you're at the end, what can we say about subjects? There's an effect of subjects, right? There's an effect. So if we have an effect, what else could we potentially have if there are other variables? We can have interactions between them. So what interactions can we have here? So we can have interactions between sub and who gets bored easily? Okay, great. So imagine that you get bored easily. I switched it just a second ago. Oh, time. Okay. So if you get bored easily, how is time going to affect you? With more time, are you going to get a lot better? No. You get bored, so you're not going to do so great potentially. On the other hand, people that don't get bored easily, maybe they're going to be able to focus more, right? So that means there could be an interaction between subject and time. What else could there be an interaction between? What? Difficult. Who here likes really hard classes?
It depends.
It depends on the subject. Granted, who likes a challenge? Maybe if I rephrase it. If you're good at it. Oh, that's so interesting because so many things can come into play. Let's say, I mean, there are different levels of the difficulty, but I would imagine that there are going to be some people that are more likely to rise up to a challenge. They're like, yeah, booyah, this is hard, but I want to show them what I can do on this, right? And other people, maybe not so much. So this means that there could be a subject by difficulty interaction. What else could there be? What?
Having difficulty.
Subject, I think that's what you meant, subject in front?
Oh, okay, yeah.
Yes! Okay. Yeah. Nice.
Extraneous variable, like how much the A, extraneous variable is?
How much would
The difference between each person.
So like these things that I've talked about, like how much you can rise up to a challenge, how quickly you get bored, all of these are what? All of these things are extraneous variables. All of these things are going to potentially influence how you do. Does that make sense? So people who haven't had a decent breakfast, maybe in general, they will all be slightly worse, right? They'll all be slightly worse because they can't focus as well because they're, actually your body's really great at regulating blood sugar, but they don't have the energy and they're feeling a bit fatigued. So in general, they all do worse. However, people who haven't had breakfast, I would predict that they're going to poop out sooner than those who have had breakfast, right? And similarly, they're not going to be able to rise to a challenge as much. So that's another extraneous variable, and that's going to influence these things, potentially. If we wanted to particularly control for something, we could introduce a new variable, and then we would have a whole lot more effects and also interactions. Multidimensional. Woo! All right, so we have subjects by time, subjects by difficulty, and subjects by time by difficulty. Do we have any other interactions? Well, to answer this, let's look at all of the effects that we're interested in. Time, difficulty, time by difficulty, time, difficulty, time by difficulty. We have everything over there that we're interested in over here. Each piece, what previously we treated as error variance, gets broken up into a lot of different pieces. And now all we have to do is pick the appropriate piece to run our analyses. So, F, we said, is mean squared effect over mean squared error, right? So, if I was interested in the effect of time, what would be the appropriate error? Mean squares it is one of these things. Think about when I did the graph, right? So we have some mean, and then we have variations around that particular point. So if we're interested in the effect of time, which of these is going to represent the variations around the different times? Subject. So just this one. You plead the fifth. That's okay. You can do that. The third one. Yes, differences. This is the one? No. And no. That's not the one. This isn't the one. There are two options left. This one? Nope. There's one left. Which is it? Subject and time. Earlier when we had everything completely between, we would have something like our mean squares for any of the effects that we were interested in, all over our mean squares for our subjects, because the subjects are what's contributing to all that variance around each of those means. But here, subjects is actually meaningful. Some are faster, some are slower. We can take that, just like we did in the t-test, and just throw that away. Don't need to use it. Cool. At least we don't need to use it here. This will make our test more powerful, which is why within designs are going to be more powerful. So, subject and time, however, is going to indicate interactions between different subjects and time. So some people do better with more time, some people might do worse with more time. Does that make sense? So who does better, who does worse? What's that? What's that due to? That's due to all sorts of extraneous variables, how much they like a challenge, whether they had breakfast, if they're interested in the material or not, right? All of that stuff. That's extraneous variables. That's pushing things up or down. That's error variance. So, if our statistic for that is a sub, where am I here? Yes. So that's the formula for this one. What if we were interested in the effect of difference? Subject. Yes, that's right. Ding, 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 ding. What if we were interested in the interaction between time and difficulty? What would be the appropriate error term for that one? Last one, yes! Subject by time by difficulty. Beauty. So let's get back to our first thing. And this was 5, 10, wanna, want, and no wanna. So we can break our total variance up into pieces. What are the pieces that are related to the effect? Time. Yes? Want. Yes? Time by want. Okay, how do we break up the error, right? Because we have error variance. Everything else is error variance, but we can break it up. How are we going to break it up? What do the points around these things mean? They're subjects, they're people. Do any of the points go together? What? No? 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 No?
No.
No? 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 No?
Go with no.
No? 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 Yes! Yes!
I've never trusted anything again.
They do. Think about the people that don't wanna. We test the person at 5 minutes that don't wanna do it. We have them study again for 5 more minutes.
I thought you said they all have to, they were all exposed to both.
Uh-huh.
Both of the don't wannas, yes.
Oh, yeah.
Right? So I think we might be getting some of the designs confused because last time we had everyone, it wasn't 5 and 10 and wanna, no wanna. What was it? It was difficulty, right? And I said, yes, each person performed each difficulty in each time. Here though, we have one group of people performing at both times, the no wannas, and we also have a different group of people, but the same individuals at 5 and 10 minutes. So yes, we can break things up. We can break it up into subjects and other stuff. What is that other stuff? We'll talk next class.